All right, in this video we're going to look at a couple of different things, one being arc length and the other being area, and specifically sector area. So the length of a circular arc. So if we have, if we think about a circle and we have some angle of that circle, so we don't want to look at the whole thing, we just got a portion of this circle. So I'll say that this angle here is what we're going to call theta, right? That's our, whatever that angle is. That could be 45 degrees, that could be 30 degrees, whatever that angle is. Now again, for the formula's sake here, we are going to want our angle in radians. So if it is a degree measurement like 40 or 35, you do need to convert that to radians before you use this formula. So I've got some angle. Let's say I want to know the arc length on the outside of the circle here over that angle, right? So what is that arc length? That's what we're after. The formula for that is that the length of that arc, which we're going to call S, okay, so the length of the arc is going to be the radius, whatever the radius of this circle is, times the angle in radians, okay? So that will give us the length of that arc. All right, so 3 examples here that deal with this formula. One, find the length of the arc with radius of a circle with radius 10 meters that subtends a central angle. So what that terminology means is that the angle that we're dealing with is 30 degrees, and we just want to figure out what the arc length on the outside of the circle is there of that 30-degree angle. So the radius of the circle is 10 meters. Our central angle is 30 degrees. Again, the first thing you need to do is, if your angle measurement is degrees, you need to make sure that you use the radian equivalent to that. So that's pi over 6. Then I can use my formula. So my arc length is going to be the 10 meters times the angle pi over 6. And if I simplify that, I get 5 pi over 3. I'm going to leave it like that. You could give me the decimal equivalent to that. But that's an exact answer, 5 pi over 3. And then what is the unit of measurement? Well, if the radius is in meters, the arc length is also in that same measurement. So that's 5 pi over 3 meters. The confusing thing there is you look at 5 pi over 3 and you may think, well, that's an angle, because that's what you're used to seeing an angle look like in radians. But this is not an angle, okay? This is a distance in meters. Again, if you want to get the decimal equivalent to that so that it makes more sense to you, you can do that, but this is the exact answer, 5 pi over 3 meters. Okay, a central angle, theta, in a circle of radius 4 meters is subtended by an arc length of 6 meters. Find theta. So same formula, but now I have the arc length, that's 6. I have the radius, that's 4. I want to figure out what my angle theta is. And so if I divide by 4, I simply get that the angle theta is 6 divided by 4, which would be 3 over 2. And then anytime we're dealing with this formula, our angle theta is in radians. So this is 3 over 2, or 1.5 radians. Now again, that doesn't look like a radian measure that you're used to if you're used to the unit circle. However, this is an angle measure in radians, 1.5 radians. Okay. Last one, during a certain trip, the 32-inch tires, so this is a diameter, 32-inch diameter tires of a car made 5,000 revolutions. How far did the car travel in miles? Okay, so what does that mean? Well, if we think about a car tire going around, right? So if you think about, you have a car tire, and if it goes 1 revolution all the way around, then the distance that it has gone is that circumference, right? It's whatever that angle is that you have gone around, which again would be, if it was 1 time, it would be the circumference of that circle. So this car tire has gone around 5,000 times. So we want to figure out what the angle is that would represent 5,000 revolutions of this circle. Well, if we went 5,000 revolutions, that means that we did an angle of 2 pi 5,000 times, which means our angle is going to be 10,000 pi. Okay, that is 5,000 full revolutions. This was 32-inch diameter of a wheel, which means the radius that we're going to be dealing with is 16. So I've got everything I need here, that the arc length is going to be r, which is 16, times theta, which is 10,000 pi, and that would give us an answer of 160,000 pi. And then what's our unit of measurement? Well, the radius was in inches, right? This is 16 inches, so this is in inches. And we want to know how far did the car travel in miles. So it went 160,000 pi inches. What is that in terms of miles? So I'm just going to do a conversion here, a couple conversions. To get rid of the inches, I'm going to put inches on bottom. I'm going to go to feet first. So in 1 foot, there are 12 inches. And then I also need to get rid of feet to go to miles. And in 1 mile, there are 5,280 feet. So what I'm really doing here, you can hopefully see the unit conversions here. The inches would be canceled here. The feet would be canceled here. We would be left with miles, which is what we want. So we're essentially taking 160,000 pi, and we are dividing by 12 times 5280. So if you do that, 160,000 pi divided by 12 times 5280, I already have this done. The answer here is 2.53. So just 2.53 miles is how far that car traveled. Okay. Area of a circular sector. So same idea kind of set up here. We've got a central angle of theta, radius r. We want to know what the area of that sector is. So if I want to know what is the area of this sector where I have whatever that angle is, how much of that circle do I have there, right? What is the area of that? And the formula for this is that the area is 1/2 times r squared times theta. Now, hopefully this formula would make sense if you thought about what would the area be all the way around. Well, all the way around would be the full circle, which would be an area of pi r squared, and that means that our angle was 2 pi. So if you imagine placing 2 pi in for theta, 2 pi times 1/2 would be 1 pi times r squared. We would get pi r squared. So that makes sense. And then going off of that, we can use this formula to find the area of any sector that is not the entire circle. So if I want to find the area of a sector of a circle where the angle is 60 degrees and the radius is 3 meters, just like the other formula, I need to make sure that my angle is in radians. So this is I'm going to think of this as pi over 3 radians, and then our area is simply going to be 1/2 times 3 squared times the angle pi over 3, which would be 1/2 times 9 times pi over 3. If it helps, put that 9 over 1. And then essentially what we've got here is 9 pi over 6, which reduces to 3 pi over 2. And then our unit, we're finding an area. So our radius was in meters, so our area is in meters squared. And that is how we find the area of a circular sector.